Hello everyone, my name is Vivek Sharma. I'm an assistant professor, precision water management specialist in the agriculture and biological engineering department at University of Florida. So I joined this position last year. Before that, I was working as an assistant professor, irrigation specialist in University of Wyoming. So today in this presentation, I'll talk about two different projects related to irrigation and nitrogen management. The first one is the ongoing study in which we are trying to understand the effectiveness of production, rotational production as a best management practice to reduce the nitrogen input and irrigation water use in Sweeney River Basin, Florida. The second project I will talk about that we concluded back in 2019 in Wyoming, where we were trying to understand the integrated effect of irrigation and nitrogen management on sugar beet production. So first I'll start with the rotational production project in Florida. So let me give you a brief background why we started this project. So this is the quote I took from the Wall Street Journal published in December 2019, that the water war that defined the American West are heading east. And I believe under the current scenario, this statement is very accurate, especially in the south eastern part of the states, where we are right now, we are facing very water management challenges. There are many reasons associated with that. One be the increasing competition of water resources among different sectors and regions also, climate variability, policy transformation. If you look at the situation in Florida, this map is showing you the projected or anticipated increase in the irrigated acres in the state of Florida. And you can see in some contests, we may see about 75% increase in irrigated acres in next 20 years. We divide the state of Florida into 5 different water management districts. And one water management district that stands out is the South Sweeney River Water Management District, which is the north central part of the Florida, in which we are seeing about an average of 37% increase in irrigated acres in next 20 years, which is also 8% increase in the Florida water use. This area is also concentrated, highly concentrated agriculture production with the overhead sprinklers. And this is also the area where the uh, upper Floridan aquifer lies, which is highly unconfined, highly permeable. And because of the intensive agriculture practices in the region, what we have seen over time is increasing concentration of nitrate, nitrogen in the upper Floridan aquifer. So to address these challenges, back in 2008, Florida Watershed Restoration Act, as well as Florida Department of Environmental Protection, set the total maximum daily load TMDL for nitrate to 0.35 milligram per liter for the Swanee River. Now, Swanee River is the important component of this upper Floridan aquifer region. And to meet this target of nitrate of 0.35 milligram per liter, they have started different basin-wide management action plans, which we call BMAPs. The idea is to to develop projects at the increment of 5 years with the specific goals in order to achieve this load reduction. And one of the project that was proposed at that time is the rotational production, which is the less intensive mean of farming, and thereby suggesting the potential for it to become an advanced best management practice. So if you look at the conventional crop rotation system in the region, in the Sweeney River Basin, many producers go for corn peanut rotation, in which they use rye as a cover crop between the two growing seasons. Another popular crop rotation system in the area is the corn, carrot, and peanut rotation. Both systems are very resource intensive, especially corn and carrot, in which you have to apply a lot of nitrogen in the growing season. what was proposed at that time is a sod-based rotation in which including 2 years of bahia grass followed by the conventional production system corn peanut or corn carrot and peanut and followed by two bahia grass growing seasons. So many producers are now using this rotation as their production management. But at that time, a couple of years back, what was missing is the long-term data, whether those production systems are effective or not. So the objective of this study is to determine the effect of four different crop rotations. That is the corn peanut, corn, corn carrot peanut, and the two bhaiya grass, 2 year of bhaiya grass, and their effect on nitrogen mass balance, nitrogen leaching, and compare it with the standard growing practice. And we add 2 years of bhaiya grass and with the cattle grazing on it. So we conducted this study in the Sweeney County at Live Oak, where we have the University of Florida Institute of Food and Agriculture Sciences, North Florida Agriculture Research and Education Center. So we conducted this study in a parcel of 70-acre parcel in which we cut about 40 acres of irrigated acres. That 40 acres we further divided into four different sections. One section is the further split into two more sections in which we have corn peanut and peanut corn continuous rotation. The other section in which we have the corn carrot peanut rotation, and the last two sections where we have bahia grass included in the conventional cropping system. So this is again, I want to emphasize, this is the long-term study. We are in the third year of the project, in which we have corn peanut corn rotation, as well as 1 year one rotation of corn carrot peanut. But in the bahia grass, we are just starting in the third year, in which we are planting corn right now after the 2 years of bahia grass. So the idea is to collect all the data set related to soil sampling, plant tissue, as well as nitrogen leaching. In this presentation, I'll more talk about the lysometer data. So for the lysometer data, we installed about 48 lysometers, that is the drain gauge decagon device lysometers. 8 in each section. So you have 8 in the corn peanut, 8 in the peanut corn, then 8 lysometers in the corn, carrot, and peanut rotation, and respective to the bahia grass treatments. Those lysometers were installed in 2018 in January. Then we have a period of about 1 year where we didn't do anything, and then the actual planting for the rotation started in 2019. So the idea is to collect the water samples from those lysometers, as well as the volume of the water that is being collected. The water samples then further send it to the lab for the nitrate, ammonia, and the total nitrogen, as well as total organic carbon measurements. So we use those volume as well as concentration data to evaluate how much nutrient leach over the growing season, as well as after the periodic sampling dates. So as I mentioned before, I will just talk about the lysometer installation or lysometer data for the two growing season for different sections. These are some of the images where we are installing the lysometers. So we install those lysometers at 48 locations at 4 feet depth. Sorry. So this is the preliminary data from those lysometers. So first I'll talk about section 100, which is more of a peanut corn rotation, in which the first year was peanut, followed by the follow period in which we have cover crop rye, then followed by the corn growing season. This orange data points are the nitrogen leaching pounds per acre. And this yellow dots are the nutrient application that we have in the corn growing season. There was no nutrient application in the peanut growing season, being a legume crop. What we observed, there is a small amount of leaching observed in the peanut growing season, followed by the heavy precipitation event. Most of this nutrient leached is because of the residual nitrogen present in the system in the soil. Now, there was very minimal amount of nitrogen leached uh, in the uh, in the follow period, but we have a significant amount of leaching observed in the corn growing season. One leaching event that stands out back in uh, June 2020, where we received about 8 inch of rainfall, and if we select a period, it was about 10 or to 11 inch of rainfall in about 1.5 week, where we saw significant high leaching events. That led to the overall leaching of about 150 pounds per acre within the growing season. And then again a follow period in which we didn't see much of the leaching in the system. The second is about 200 section, which is a corn peanut, in which corn was grown before the peanut production system, and we applied nitrogen, as you can see with the yellow dots. And they're similar to the 100 plots. We have seen leaching in the corn, and then followed by the peanut growing season, in which where we didn't where we applied only 12 pounds per acre of nitrogen throughout the growing season, followed by that precipitation event that happened in June 2020. But this, I think, one of the reasons we saw this significant leaching is because of that one particular event that was about 40 pounds per acre, followed by the 8 inch of precipitation event. If you look at the other production system, that is the corn, carrot, peanut, this is very resource intensive production system in which we see actually majority of leaching that happened. First is the corn, in which we saw about 100 pounds per acre leached, specifically after the high precipitation events. And then there's a follow period in which we didn't see much of the nitrogen leaching. And then again, about 100 pounds, close to 120 pounds acre per acre of nitrogen leached in the carrot growing season, in which we have about 250 pounds per acre of nitrogen applied. Uh, this again in the peanut growing season, one, because of the high precipitation event back in June, about 8 inches, we saw significant amount of nitrogen leached, about close to 75 pounds per acre, which we have, because of that we have the high cumulative leaching in the peanut growing season. One other thing that we saw is this 300 plots where we monitored those lysimeters individually. Also, what we saw that specifically in those particular location, which is a low-lying area, there may be some intrusion of shallow groundwater table, shallow groundwater table, that because of that we are seeing the high concentration of nitrogen and nitrogen leached in those measurements. And because of this intrusion of the ground shallow water table, we might be measuring those nitrate for the same water that is already being measured. That might be the one reason we have seen these three lysimeters are substantially high in volume, as well as high in the nitrogen concentration, that led to the increase in the cumulative nitrogen leaching in the 300 sections where we have the corn, carrot, peanut rotation. Right now we are trying to understand the effect, how we can exclude that amount of water that being included into the lysimeters from shallow water table. If you look at the sod-based rotation, which is, you can see there is a significant less nitrogen because we don't apply any nitrogen in that setting. We applied only about 50 pounds, close to 50 pounds of nitrogen in 2019 as well as in 20, and we we let cows in for grazing in 2019 around in October and about 50 days, and there may be some manure or cow waste present in the field that led the nitrogen leaching event back in early January. And we saw amount of leach, you can see significantly lower, is about 40 pounds per acre compared to the other treatment. Again, this is an ongoing study. The next year is this corn that will tell us a more clear picture on the complete cycle, in which we have 2 years of Bahia grass followed by corn and peanut rotation. This is a side-by-side comparison of all the production systems that we have. This section below is color-coded, each color representing a nitrogen leaching events or nitrogen leaching line for that section. And you can see, because of this one particular event, we have seen a significant amount of leaching happen in all the plots, specifically in 300 plots where we have corn, carrot, and peanut rotation, and as well as where we have seen some intrusion of shallow groundwater table into the lysometer. So this is again the preliminary data. What we saw is the average nitrogen leaching fluctuate between the sampling dates and sample dates. Maximum leaching occurred in the section where the corn was grown, and corn and carrot was grown, because it's a very resource intensive system, compared to the other sections where less fertilizer was applied. Corn and peanut residue were left in the ground after the harvest, and that also mineralized may result into the nitrogen nitrate leaching in the fallow period. So this is all about the rotational production system project. Now I'll switch gear and talk about the irrigation and nitrogen management on sugar beets. This project, as I stated before, was conducted in Wyoming, which is very arid and semi-arid part of the region. Why we started this project back in 2016 is because one is the sugar beet is very important crop to the Wyoming. Since because of the arid climate, irrigation is an essential component of that system. Without any irrigation, there is no possibility of growing any crop in the state of Wyoming, because it's very arid and high evapotranspiration demand. Another thing that we saw is, one of the common irrigation practice is the surface irrigation there. But in recent years, what we have seen is most of the producers are leaving that conventional system and moving to the more precision agriculture irrigation systems, that is overhead irrigation systems. We met the advisory board, and one of the challenge was how we can develop new recommendation for nitrogen as well as irrigation under sprinkler irrigation for sugar beet production. So we started this project in the Power Research and Extension Center. The idea was to understand the integrated effect of irrigation and nitrogen on sugar beet production, evapotranspiration, as well as crop coefficients. We used this 9-span variable rate irrigation system, in which we have 3 irrigation treatments, 1 full irrigation treatment and 2 deficit irrigation treatments, which is 75% of full irrigation and 60% of the full irrigation. And we have 5 nitrogen treatments. The nitrogen treatments was split into 2 applications, 100 pounds per acre of nitrogen at pre-plant for all the treatments. And then we use the variable nitrogen from 0 to 150 pounds per acre of nitrogen at the time of side dressing, which led to a total nitrogen variation about 100 pounds to 250 pounds per acre of nitrogen. Sorry, my units are wrong here. These are some of the management practices that we used throughout 4 growing seasons. We tried to maintain all the practices same. The only difference that happened in 4 years is the variety. For 2 years, 16 and 17, we used different hybrid compared to 18 and 19, which is a different hybrid. Rest, all the management practices stay same. We use a water balance approach to calculate the crop evapotranspiration. We installed various soil moisture sensors as well as Newton probe to accurately monitor the changes or variation in the soil moisture throughout the growing season. We weekly monitored the soil moisture variation using the Newton probe. And then we use this water balance approach with the data from the Powell climate weather station for the precipitation, and we also monitored how much water we are putting in, so that we can have all the component of the water balance to extract the crop evapotranspiration. Once we have those ET values, we also use calculated various water use efficiencies, crop water use efficiency, irrigation water use efficiency, as well as crop coefficient. In addition, we also collected all the crop physiological data, which is the leaf area index, plant height, canopy temperature, etc. In this presentation, I just concentrated on the yield and the ET part of that. So at the end of the growing season, we topped off the sugar beets, and then we use sugar beet digger, which is the 2 rows sugar beet digger, in which we harvested the 2 center rows for the yield analysis as well as the sugar analysis. So for the sugar analysis, we collected randomly 8 to 10 beets, packed them separately, and then we sent those sugar beet samples to the Western Sugar Lab in Billings, Montana, for the sucrose or the sugar analysis. In terms of the climate condition or the weather conditions for the 4 growing season, we were lucky to have the very different growing seasons. As you can see here, the numbers on the top of the bars is the seasonal change from the long-term average. So in 2016, the precipitation is 0.5 inch less compared to 2019, where we see 3 inches more. We receive 3 inch more rainfall in compared to the long-term average. Similarly, reflected in the temperature, average year temperature, where 2016 was 1 degree hotter compared to 2019 and 18, where we see 1 degree lower air temperature compared to the long-term average. And that also reflect our precision irrigation. You can see variation in the irrigation water that we applied varies from 21 inches to about 15 inches in 2019. So these are the results in the sugar beet yield. What we saw is sugar beet yield increase with both increase in the irrigation as well as nitrogen rates for all the years. We received maximum yield in 2019 about 83 tons per hectare in the higher nitrogen irrigation and full irrigation treatment, and the lower we received in 2018 about 30 tons per hectare. You can see there is a difference in yield in 2018 compared to 16, 17, and 19. What happened in 2019? Back in July, we have the irrigation sprinkler breakdown, and for 2 week period there was no irrigation. I think that one of the reasons we saw lower yield in 2018 compared to the other years. What interesting is the sugar data. At the end of the day, what we are looking is optimal tonnage as well as the high sucrose content in the beets, because that's the earning, that's the money, wherever the money is. So in terms of sugar, what we saw is there is an optimal nitrogen level for each irrigation treatment, and in general, medium nitrogen applications, which is close to 180 pounds per acre, will give you the acceptable tonnage as well as the maximum sucrose content. I just want to say I tried to. I mean, most of my units are in metric units here. I'm sorry for that. So what we saw is maximum percent sugar that we got is about 19% in 134 kilogram per hectare of nitrogen, which is 120 pounds per acre of nitrogen under full irrigation requirement. And the minimum that we receive about 14% under the very high nitrogen treatment, about 250 pounds per acre under full irrigation requirement. We also looked into the evapotranspiration. What's the potential difference in the ET among different nitrogen and irrigation treatments? You can see this 3 graphs here. It's showing you the cumulative amount of evapotranspiration as well as precipitation, irrigation that we applied, and the actual reference evapotranspiration, both on grass and alfalfa base reference surfaces. For full irrigation, 75 and 60% irrigation. What we saw here in 2 graphs, it synthesized all the result. We saw significant differences in ET as expected in different irrigation treatments, but we did not see any difference in ET among different nitrogen treatments. This is the average effect of all the treatments. This is just an example data from 2018. And similar observations were observed in 2017 and 19 as well as in 16. Further, we developed the crop production functions both on the yield basis as well as on the percent sugar basis. On the y-axis, we have yield and percent sugar. On the x-axis, we have the ET. What we saw is the sugar beet tonnage increase linearly with increase in evapotranspiration, and then on average, sugar beet yield increase at a rate 0.08 to 0.15 megagram per hectare per millimeter of ET. For the sugar beet water use efficiency, we saw about in the range of zero point zero 0.06 to 0.13 megagram per hectare per millimeter of water. We got the higher water irrigation water use efficiency in the range of 0.09 to 0.31 megagram per hectare per millimeter of water. There was no significant relationship was observed with the percentage sugar versus ET. However, what we observed is percent sugar was higher in the deficit irrigation treatments and the lower nitrogen rates. So in conclusion, what we saw is the sugar beet yield increased with the irrigation, both in irrigation and nitrogen. For all the years, irrigation had a significant effect on the sugar beet yield, ET, and percent sugar. However, nitrogen treatment, we did not see any significant effect on evapotranspiration, but there was an effect on sugar beet yield and percent sugar. Our result indicate that there is an optimal nitrogen level for each irrigation regime, in which in general medium nitrogen application rate, which is 180 pounds per acre, will give you the acceptable tonnage as well as the maximum sugar content. Over 3 years, maximum water use efficiency and irrigation water use efficiency was observed for deficit irrigation plot as expected, which is 75% of the full irrigation requirement for higher nitrogen treatment. So this is all about the two studies. I would like to thank many people. I listed a few of them here. Dr. Charles Barrett, who is leading the crop rotation study. Dr. Jim Highhold, who is the director of Powell Research and Extension Center. My graduate students, as well as funding agencies, Florida Department of Agriculture and Consumer Science, as well as Sweeney River Water Management District, UST, and Western Sugar. With that, I'll stop here and thank you for your attention, and I'm open to questions. Thank you.